Hi. Let's assume you have chosen the ADS Max for your lab program and you want to teach more topics. The ADS Max ecosystem supports multiple course options from EMONA. In this overview, we will describe the EMONA Wireless Communications Board option. The DxIQ. The EMONA Communications Board is a collection of functional circuit blocks which are patched together by students to build real-time communications experiments to study in depth. Building experiments following a block diagram approach enables many experiments in the one system. More than 20 fully documented step-by-step experiments are covered in the included lab manual, and you can easily create your own. For example, take the equation for QPSK, normally represented as a block diagram. This block diagram is patched together with real circuit functions to implement a real-time electrical model of the QPSK system. Let us take a quick look at Lab 12 in the DxIQ Lab Manual on QPSK modulation and demodulation. Fully documented step-by-step procedures are provided. Students will use the waveform software to control the instruments in the ADS Max. Each experiment is patched together from the selection of circuit blocks, oscillators, data sources, adders, multipliers, filters, etc. as required. And a 4-channel scope plus 2-channel function generator is available. At this stage of the experiment, students will already have modulated the data stream onto I and Q branches and added them together at the passband, controlling the relative amplitudes of each branch. View this in the time and XY modes. Adjusting the phase relationship with the receiving carrier enables students to experience the importance of correct phasing, and viewing the data as a constellation further reinforces this. Viewing the QPSK signal at passband is also important, and we can vary the time base to see the phase transitions in the carrier due to the baseband data in each branch, or together. Adding noise and band limiting in the passband is part of the experiment, and band limiting at the receiver can also be implemented. Signals can be viewed as I patterns, and signal-to-noise versus bit error rate can also be measured and plotted if required, and compared to theory. Using the built-in spectrum instrument, students can view and measure signals in the frequency domain for both baseband and passband regions. More than 20 separate experiments can be implemented with the EMONA Communications Board.